and we are going to chat all things exponents, relations, and functions, getting ready for this here quiz tomorrow. So, very first part is what we were doing yesterday. So if I needed some assistance, I could break out my notes here. But I can hardly get to it. All right. So when we're doing a picture and we're trying to figure out if it's a function, reminder, we're going vertical line test. So again, that is just taking some sort of a straight edge. And as you work through, hoping that you're only going through one point of your graph. But if you get to any places, let's say here, I'm just going to draw a line. And it's going through your picture in more than one place. That is not a function. Now, I did mention on here domain and range, because there will be some questions tomorrow that you need to know that. So I'm going to discuss that on a few of these. So this one that we're doing, if I was asked for domain and range, first things first, I don't see any arrows, so I'm not going to have any infinities. But remember, domain is my x values from the furthest point left, so there's my furthest point left, to my furthest point right. But I only care about the x value of them. So if I kind of count this back down, -1, -2, -3, and my furthest point to the right is right here, 1, 2, 3, 4. And I'm going to use interval notation to show the furthest point left and the furthest point right. When I do range, I'm doing my y values from the bottom point to the one on top. You're like, well, Hardy, those are both like equally high. It doesn't matter which one you use then. So same idea. What's the y value right here? -1, -2, because I'm just lining up with my dot. And here, 1, 2, 3, y equals 4 when I count up on the axis. With that. You're going to have domain and range on a lot of questions. So you're going to have to be able to tell where's the high point, where's the low. If there's an arrow, which infinity is it? That's why we're kind of... Whatever you're seeing right now is fair game tomorrow. Whatever you're seeing right now is fair game tomorrow. Notes, just like it always is. So that's why I'm kind of referencing back and forth as we're doing this, because we did some domain and range stuff on the notes yesterday too. So let's say, let's try something different. I'm going to get away from number 3 for a moment. Do I want, no, I do want to do number 3 because it's kind of weird. So you're like, okay. So I kind of start to go along here. I'm like, okay, Hardy, this doesn't even cross. Oh, wait a minute. Okay. So the one line that's here, but like it covers like every line ever made.
Alexa Britton. You need to take your Chromebook and put it down from the end.
And so here, this is also not a function because that's a whole lot more than one point that my vertical line goes through. But here's where it gets a little stranger. If I was asked to do domain and range on this one, okay, domain is my x values. You're like, well, wait a minute. Like, this is the only x value, like right here. 1, 2, 3. Because no matter where I go on this line, the x value is 3. So how the heck do I do that? We just take 3. That's the only number for our domain this time. That's kind of weird. I wouldn't do that to you on a quiz, but it's good to know for future reference. Now my range. Oh, I see arrows. I see arrows. We're going down forever. So my bottom's at negative infinity, way down here. And I'm going up forever. Absolutely. If it were horizontal, if the line was like this, yeah, the range would be one number and the domain would be infinite. Very good. Yes, sir. Ooh, another good question. So why did Hardy all of a sudden change from brackets into parentheses? So brackets mean we're including a certain number, a certain endpoint, like there's a closed dot there. If there's arrows, there's really no end. It never stops going. So that's why we're always, when we see the infinities, are always going to use parentheses. But I'll be 100% honest with you. If this was the quiz and you had the numbers right, but you used parentheses instead of brackets, I'm not going to mark it. So now you got me on tape saying it. So if I do to somebody, you remember that 6-minute and 8-second mark of the video and say, Hardy? So question for somebody who might have some confidence here on number 5. Remember, when we're trying to figure out if it's a function or not, you only care about the x values. Is this one going to be a function? Nope, why not?
There's 2 3s.
There you go. We have the double 3 here in x. That's not good. All your x's have to be different for you to have a function. But if I was asked for domain and range, you're like, okay, I don't have a picture this time, Hardy. This is kind of weird. If I don't have a picture, if I just have a list of numbers, we did talk about this yesterday. All I'm going to do for my domain, you're like, dang, it's another symbol. Yep. We got the brace here. The brace is for when we have individual numbers. So all I'm going to do is I'm going to list off each of the x values. I don't have to put 3 twice. I mean, if you did, it wouldn't be terrible. But normally, if it's the same one twice, we don't list it twice. So we just list all the different x numbers. And we do the same thing with range for our y's. We're just going to list all of these. We're not using the brackets and we're not using the parentheses because it's not every number between 4 and 16. It's just these numbers. It's not every number between 0 and 5. It's just these particular numbers that we're trying to find. All right, we got to find... Let's go back up to number 2. I wasn't going to do any evens, but I'm like, I need to find something that's actually a function that we can be like, Hardy, something's got to be a function. So if I have a chart, now, all the x's are different, that's good. But what I'm looking for here is, does each input, does each x only go to one y? And if I check that out on this one, that is true. 6 goes to 5, 10 goes to -3, 14 goes to 0, 23 goes to 5. So this is absolutely, positively, yes, 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 yes. And if I went to do domain and range here, again, just list off your x values here. If there's a list, if they're coordinate points, if it's a chart, this is exactly what we're going to do every time. And then -3, 0, and 5. Do I want to do one more? I do want to do one more. One more. Number 6. Number 6. All right, so I'm going through. And again, if I stop at any point, as long as I'm only going through my graph in one place, again, the axis is not included. Works good so far. And we made it. Okay. So this one's a yes. But domain and range this time, that's a little more interesting. So remember, left to right. These arrows don't stop where the arrow is. They keep going. So this arrow is continuing to go out to the left forever to negative infinity. over here, this arrow is not only going down, it's also slightly going out to the right. I told you when there's arrows, there's going to be a lot of infinity speak when we're doing these. Bless you. So then range is my y values from bottom to top. Well, I'm going down forever. So we're starting at negative infinity, but I'm not going up forever. Find that top point. Let's see here. 1, 2, 3, 4. And that finishes us off. So the big thing with these, probably more than anything else, is the domain and range stuff. But between the practice yesterday, if you haven't done it yet, I would. And then these, that should probably get us in pretty good shape as far as most of our function issue goes. Now, however, I got to let you in on a couple things. I want to look at one thing before I say this. Yep, I'm going to say it. Be prepared tomorrow, FYI. We're going to add a question at the bottom of the front here before I flip over to 15. So if I give you okay, f of x, just function notation for y equals 4x plus 6. Find f of negative 2. All we're doing is taking that number in the parentheses and plugging it in for the x in the problem. Don't worry about this. We're just plugging it in here. So we'd have 4 times negative 2 plus 6. Then we're just going to find the answer. So negative 8 plus 6. Hey, it's also negative 2. What a coincidence. So it's just substitution. I just don't want you to freak out when you see it. Be like, wait a minute. What am I supposed to do? Plug the number of parentheses in for x and just get the answer. Because I forgot to put that on the review, and I didn't want to forget it and then have it show up on the quiz. Okay. Now back to the regularly scheduled programming on page 15. Okay. We have these notes if you end up needing them tomorrow, just as a reference. Let me pull these out. So these are on page 7 of your notes if you're trying to make a reference point. So when we're doing exponential form, remember we're taking what's here and it's the exponent over the root, over the index. So sort of like, let me fold this over. Okay, so there's my example. So I'm like, okay, so 6v, the exponent goes on top of my fraction, the root goes on the bottom. I'm done. Hardy, do I have to have the parentheses? Yes. Because I want that 5/3 to the 6 and the v, not just the v. And so you're like, all right. 7v in parentheses. 5, uh-oh. What's my index number when I don't see one? 2. Because it's a square root. It's not 1, like it's an exponent. And again, that's it. I'm done. And so if we're going back the other way then, I'm going to use the same example. So I look, I'm like, all right, so n, looks like the exponent goes inside here. So that's the exponent. And then the number in the denominator of the fraction is the little root number. And we're done. So don't make life complicated. Exponent, root. Do I need the parentheses? Uh-huh. Because otherwise the 3 only goes to the x. It doesn't go to the 2. So now, to avoid freak-outedness, we're going to do we do 5 and 8? 5 and 8, 7 and 8. 5 and 8. 5 and 8. Okay. Exponent rules. Let me fire this one back up. I want to say it's page 5. Good job, Hardy. It is page 5. Page 5. Or page 1. It depends. So, first thing. Big numbers don't play by exponent rules. If you see big coefficients and it says to multiply, you multiply them. 12, okay? Now the other variables, I have x to the 1/3. That's the only x I have. So that's cool. But now this y stuff, when we multiply, we're adding exponents. So I'm going to have y to the 3/2 plus -2. All right, I'm going to get myself a little help here. 3/2 plus -2. Math enter, enter. Okay, so here's where we're at. We got 12x to the 1/3, y to the -1/2. Now, if you got there and stopped, you've got most of it. Your answer should contain, we don't need the last part, only positive exponents. So how do I undo a negative exponent? We got to flip it. So we're going to make this a little fraction. All this stuff that's positive right here all gets to stay right where it's at. It is behaving well. It don't need to do nothing. But negativity, oh no. Negative, you get flipped. Once all your exponents are positive and you don't see the same variable more than once, you're done. That's it. And so when you're playing with all these, the other thing you could do, and I'm actually going to do on number 8, so you can kind of see there's options. If you see negative exponents, sometimes I will go ahead and I will rewrite the problem. And all I do when I rewrite the problem is take anything with a negative exponent and I flip it. So that -3/2, I flipped to the top, became positive. Y to the -1, I flipped to the top, it became positive. The only thing that stayed is the 4, because that -3/2 only goes to x, not the 4. Well, that's easy up there, but this is going to be a little crazy. So I'm looking, and I'm like, all right, I got x, I got x, I got x. I need to add all those up. Now, do you have to write it out like I am right now? Maybe not. But I'm doing it because I want you to see what I'm doing. So I got to add all this stuff up. I don't need the x. So 2 plus 5/3 plus 3/2. No decimals. All you have to know tomorrow is the rule. And you have this to tell you what the rule is. The calculator will do all the rest of this. And then y, I think I can handle 2 plus 1. So whether they're fractions or whether they're whole numbers, the rules don't change. And that's going to be the same thing down here below. So I'll do one of these. I'm not going to go crazy down here at the bottom because we just kind of saw a whole bunch of the rules. I do want to do one of these, though. I want to do 11. That 4 goes to the 3 into each of the exponents here. So I've got 3 to the 4th power. When we distribute the exponent, we're multiplying, okay? Right there, multiply the exponents. So we got x to the 3 times 4, and we got y to the 3 times 4. And again, if you can do that in your head right away, go for it. 3 to the 4th power is 81. 3 times 4 is 12. And 3 times 4 is 12. And we're ready to roll. But again, make sure you don't have negative exponents in your answer. We got to flip them, we got to add them, we got to do whatever, but we got to make sure that we get them right. Do I have one more? Do I want to do that one? I'm not going to touch that one yet. Not going to do it. Oh, that's right. This is the end, isn't it? Do I want to do one more? I do want to do one last one. I want to do 14. Then I swear I'll be done. Okay. So first I look at the big numbers. I'm like 3 divided by 2. It's 1.5. Math, enter, enter. Well, Hardy, it's still 3 over 2. Then leave it that way. Don't turn it into a decimal. M's, we're dividing. So you can either do one of two things. You can say, okay, I'm going to do m to the 1 minus 3. And then n's the only other one here. Now, here's the one thing. So I'll show you a trick to shorten this up. So if I do that, I have a negative exponent still, so I got to do this one more step. 3 is okay. M flips to the bottom because it has a negative exponent. And the n stays. Now, that works. The other thing you can do as far as division goes, if you start with the bigger number, so here with the m's, if you start with the bigger number and put it there, so the 3 is bigger, it's down in the bottom, I put it there instead. Now, when I do my subtraction, I end up with the same answer, but I had like at least one shorter step, if not 2. So that's the other way you can use the division rule if you want to. But other than that, I mean, that's it. I mean, rational exponents, regular exponent rules, domain and range type stuff. So it shouldn't be a real long, real tough quiz tomorrow. But I still would have my practice done, just saying, just in case. And if you need that, if I can move this. Oh, I still got to get my list up. Okay, well, I will do that here momentarily. So let me